believe this is question 11 on 7.3. I think they ask you to find the sine and cosine of an angle whose terminal side goes to the point -3/5 and 4/5. If you read the question carefully, it tells you this is a point on the unit circle. Okay, and even if you didn't know it was a point on the unit circle, you could graph this, and you've got your initial side going this way, and this is going to end up being in quadrant 2, so first quadrant and second quadrant, and we're going back 3/5, and we're going up 4/5. And anyway, so even if they didn't tell you this was the unit circle, you'd still be able to do this problem. Now they want you to find sine and cosine. So if you didn't know it was on the unit circle, you'd take 4/5 squared plus -3/5 squared, and you'd set that equal to c squared, or I guess r squared actually, to find your r value here. And that's 16/25. That's 9/25. It's going to be equal to r squared. And you can see here you get 25/25, which of course is equal to 1, so your radius is 1. What does this tell you? This is a point on the unit circle, okay? It's not a 30, 60, 90, or 45, 45, 90 triangle. But if we know it's a point on the unit circle, the rules still work. So anyway, long story short, that's a unit circle. Sorry for the bad drawing. It's a unit circle. We know that sine of an angle is equal to the y-coordinate. So the sine of this angle is 4/5, okay? We don't know what the angle measure is. You could use an inverse trig function to find the angle measure. I'm sure it's some ugly decimal, but anyway, that's all we need. Cosine of an angle is the x-coordinate, so it's -3/5. Again, if that totally went over your head, it doesn't matter, okay? Because sine is opposite over hypotenuse. 4/5 over 1 is 4/5. Cosine is adjacent over hypotenuse, still going to give you -3/5. So either way, you're okay. And by the way, notice something. That's actually a 3, 4, 5 triangle dilated down to have a radius of 1. So I'm dividing all of the sides by 5, and that's going to give me side lengths of 1, 4/5, and -3/5. Okay, so you might have even noticed that 3, 4, 5 pattern there. It just looks a little bit strange, but that's what's going on, and number 12 should be very similar.